In part 3 of this lesson, I'll show you how to perform the concavity test and second derivative test. The question reads, is the curve y is equal to 3x to the power of 4 minus 7x to the power of 2 minus 2 concave upward or concave downward at the points x is equal to 0 and x is equal to 1? According to this test, if you take the second derivative of a function and the output of that second derivative is positive, you will end up with a graph where y is concave up, shown in this symbol. On the contrary, if the output is negative after substituting x into the second derivative, the function y is concave down. So let's start by taking the first derivative and then subsequently taking the second. The first derivative is shown with this y prime. Y prime is equal to, and we'll use the power rule here, where we have 12x to the power of 3. So I brought my exponent down and multiplied it to the 3 and subtracted 4 from 1. The power rule once again for this term, where we end up with negative 14x, and the power rule for negative 2 is simply 0. Any constant is 0. So that's the first derivative. The second derivative, we'll use the power rule once again. We end up with 36x to the power of 2 minus 14. Now I'll substitute these values. X is equal to 0 and x is equal to 1. Y prime at 0 is equal to negative 14. We'll interpret that in a second. And y prime at 1 is equal to 36 times 1 minus 14. That gives us a positive number. And this obviously is a negative number. So at y is equal to 0 for the second derivative, we end up with a negative output. Therefore, y is concave down at that point. And similarly, y double prime at 1 gives us a positive output, so it's going to look like this at that point. I also want to show you a graphical representation of this function, not the second derivative, and it looks like this. Remember, the 2 points we were analyzing is x being 0 and x being 1. So this is x is equal to 1. And notice, right after 1, right afterwards, it starts to get bigger. It starts to become positive. And notice that this part right here is concave upwards. And at x is equal to 0, over here, it's concave downwards, which is exactly what we predicted. That when the output is negative, it's concave downwards. And there it is. That is how to perform the concavity test and second derivative test for a function.